You can do whatever you like.
È solo lui, quindi.
Not to take me because I'm not photogenic.
You're very photogenic.
Okay. I say, dimmi tu quando cominciamo.
Sì, sì.
Adesso. Okay. We are in Trieste. It's the 27th of March at the Congress Pneumo Trieste. And I'm very pleased to meet Dr. McKeon of Harvard School and Singapore Research Institute. And I would like that Dr. Professor McKeon, speaks about his study and about the perspectives of this study for patients. If you are so kind and say a few words about your study.
Thank you, Iris. I mean, it's a pleasure to be in Trieste and to meet everyone involved in lung disease. The work we presented, along with Lam at the Institute for Medical Biology in Singapore, has to do with adult stem cells that have the remarkable potential to regenerate lungs. And prior to our study, the notion that you could regenerate lungs had not taken off at this point. Oddly enough, we came to this realization through looking at mice and patients who had been infected with very strong strains of disease. And what that did was destroy large portions of their lungs. And with time, those lungs were repaired. So this gave us the sense that actually repair lungs that had been severely damaged. And when we looked into those lungs, we realized there were a group of cells, we call adult stem cells, that are able to participate in this process and regenerate lungs that had been severely damaged. In the process of doing this, we went and isolated cells from both mice and humans. And these cells have the remarkable ability to divide in culture and get these out. And in a test tube, essentially, they can form the elements of the airways, upper airways, as well as the distal lung. So this offers potential, not in any near term, but in the long term, of using these in lung regeneration processes. So there are major lung diseases, COPD and idiopathic pulmonary fibrosis, that really need these treatments. And there's the potential that Lam would also benefit from such a direction. So we are actively working with models in the laboratory at this moment to take advantage of these cells and work on strategies that would recruit these to attempt to repair damaged lungs. So that's, it's very basic research, but we have the sense that if we can get these out to more laboratories, and the technology is moving very quickly, that people will be able to, in the experimental stages, regenerate lungs. That's the real hope. That's what we're after.
Great. In how many years do you think the patients can take advantage potentially of this study?
Well, I think at experimental level, we're talking in the next 3 years. To actually make this a standard therapy could be longer, but it really needs people moving into this area and harnessing the basic power of the cells, which we think is significant.
From the point of view of low and stem cells, is it easy to use stem cells for research in the United States? We have been told by Professor Pellegrini of Modena, I don't know if you've been in touch with her.
Yeah, I know her very well.
Okay. She has told me that it's very complicated in Europe because of the laws, which are restrictive, and it's difficult to get to bring to reality the studies which she has made.
I know she's very frustrated with the rules on any cell therapy.
Yes.
honesty, I think my own view of this is they've been restricting progress in this area, which has already been proven by Michaela and Pellegrini and others to be have remarkable capacity in corneal epithelial transplants. And Howard Green has shown these in epidermal transplants for severe burn patients. Why it's been so restricted is really unclear to me. And these are adult stem cells. We're not talking about embryonic stem cells with all the problems they carry with them. These are adult stem cells that are not obviously tumor-genetic. And I think the hope is the regulatory agencies will see the balance between safety and the concerns for the patients.
We also hope. But in the United States, you think it's easier to work with stem cells than in Europe?
I think it's now starting. They're doing a number of studies now with macular degeneration, and those studies have proven to be safe. And those are even on embryonic stem cells. Adult stem cells are, in every way we can see, less dangerous than those studies. But you really have to have regulatory bodies that are able to weigh these risks compared to the benefits for the patients. So we're strong proponents in relaxing those standards, without sacrificing patient health.
Well, I thank you. You are leaving today. So one last question, maybe. Why do you have this love for stem cells? How did you get to this study? Is it something you had already when you were young? What is your...
Well, we had worked at, we worked at Harvard in the same department as Howard Green, who first cloned the epidermal stem cell. And he's worked closely with people such as Michaela on the adult stem cells. And to this day, those are the only two stem cells that have been cloned. And we took it a step further, essentially the same technology, and moved it into a whole range of adult stem cells, including those of the airway. And when you see how powerful these cells are, you fall in love with them. You just want to see what they can do for human health. Right.
Thank you very much. Right. We hope to stay in touch with you, and for us it's very, very important that people like you are studying and finding maybe one day a cure also for chronic diseases like Lam.
I hope so. You're doing wonderful stuff in an area that really needs to be solved.
Thank you very much. Thank you.